All right, everybody hear me all right? So if I don't accomplish much in wheat this year, at least I could say I gave Marty plenty of spore inoculum for his disease plots, because stripe rust blew up in our plots really quick about a month and a half ago, and had nothing related to fertility either. You know, that's one of the first questions I got. Was it high fertility versus low fertility? Nope. Took a random spot, blew up, and took about 36 hours and took out a good chunk of one of our fields, but did recover. So, you know, it's one of those things. You start talking about the tale of two seasons. There's a reason why we're inside here today and not outside. You know, I was trying to think of, pull some slides. Yesterday, I knew it was going to rain. What can we look at between last year and this year? And you look at that rainfall. If you remember last year at this point, we were scratching the soil and it was chalky. There was no moisture, several inches, in some cases feet down. You can look at the tale of two seasons. Look at April 23 versus 24, pretty normal. But you look at that May-June period, right? Remember last year the faucet shut off about April 5th, April 6th, and didn't turn on again until about July 1. And yes, we got 0.9 in May and 0.9 in June, but a lot of that happened over maybe a dozen or 14 different rainfalls of about 0.03 or 0.05 inches at a time. And this year, April was a little bit normal. May was actually a little bit on the dry side, depending where you are, right? And then I put so far here, down towards south central Michigan, 2.6 as of yesterday. We can add a little bit more onto that today. But, I heard reports, you go back weekend before last, we had a nice 4-inch rain in spots. You go back to last weekend on the west side of the state. I saw one location got 7-8 inches in about an hour and a half. So to this number right there, you're going to add 4, 6, 8 inches, depending where you're at in the state, right? And so it's going to be different. Your fertilizer plan could be different moving forward. And so that's one of those things, you've probably seen this term a lot here in the last 2 years, climate smart agriculture. And why are we talking about that? Exactly look at last year and this year, right? Wheat, I'm kind of excited to see what yield looks like because we actually had moisture this spring and summer to fill that grain head out. Corn looking pretty good so far too. But what is climate smart agriculture? Anybody tell me? You see that term pasted all over the media. Lots of money being pumped into climate smart agriculture. And I kind of lumped it into three different terms. One, it has to be productive. Right? We can't be recommending practices that aren't productive. 2, it has to be profitable. Kind of goes hand in hand. 3, has to be protective. Right? Soil quality, soil health, water quality, etc. And I look at that and what comes to mind? There's no better opportunity for climate smart agriculture than soil fertility. Right? Because you don't know if it's going to be dry or if it's going to be wet for that wheat crop. And you got to plan for both. You got to plan for 1/2 inch of rain and you got to plan for 4.5 inches of rain going into that season. And so you look at what can we do to prepare for something like that. Look at last year. Was a great year to look at sulfur deficiency. And why? Because we had no moisture, right? We had no moisture. We couldn't move much sulfur to that plant. And so I looked at a lot of our wheat trials last year, and everywhere we did not have starter fertilizer, we saw what you're looking at here, and that is a Feek 7 sulfur deficiency, where you get that yellowing towards the top of that plant. Some of us mistake it for nitrogen, but it's not. It's much different. And then you can compare that picture with last year, everywhere we had starter fertilizer, we had that Spartan green wheat, right? And that starter fertilizer had both nitrogen and sulfur in it. And why did we see that response? Because we had very little rain, right? So if you did have sulfur in that soil profile, it couldn't move to that plant. And so that's one of the things that's really changed when you look at the last probably 30, 40, 50 years. You look at soil fertility, nutrient management, and it always used to be, what is the yield response? What is the yield response? But we also have to start accounting for some of this climate variability that we're now seeing. Because we've seen it all in the last 10, 12 years, right? Hot, cold, wet, dry, etc. And so I get this question a lot of times in the fall, a lot of times in the spring, talk about it, some of the winter webinars that we put on. Does end timing matter? Well, that depends. Isn't that a great answer? It depends. Is it going to rain or is it not going to rain? Right? Because if it's not going to rain, probably a little bit less influence on that end timing. If it is going to rain, a whole lot more influence on that end timing. But I took this picture, I think early April, mid-April, and I'll let you be the judge. This is an end timing study. Look at the color of that wheat. Think end timing matters? Would you rather have that wheat or would you rather have that wheat? Kind of a no-brainer, right? So yes, end timing does matter. That's something we've looked at the last couple of years. So I pulled a couple pictures from this spring. You can see our beautiful looking check plot here with no N application. And we've kind of focused on autumn N application, right? What can we do in the fall? And that's not, in this case, not just the starter N application. I wanted to see, what if I put all my N on the wheat in the fall? Early October, what happens to it? How much yield do we lose, right? And then we looked at these freeze-up applications, which is usually, this last winter, the soil never froze, right? But if you look at this last year, probably about that first week in March is about the last time you get a spreader truck over the ground before it sinks. So that's what we call that freeze-up application. And then your typical Feeks 5 green-up application, right? And the difference between freeze-up and green-up is usually about 4 to 5 weeks. That's what it's been about the last 3 to 4 years, right? So you're looking at that early March versus that first or second week in April. And so you look at, this was taken right at that Feeks 5 growth stage, and you can see some differences showing up here. We fast forward here to Feeks 9. Now we really start to see those differences show up. And I'll ask you again, does end timing matter? Absolutely, especially in years where we have normal or sufficient, or in some cases excessive rainfall. You got your check plot, you got your autumn N only, the rows aren't filling. You got your freeze-up application, which looks good. If I didn't have this picture here, you'd be like, well, that's decent. But then you start looking over here. Wow, it looks a heck of a lot different. And that's one thing I've noticed over the last several years. If you want to figure out if your flag leaf is insufficient or not insufficient, one thing that I've picked up on is look at these flag leaves and how they're positioned. See how they're flopping over? That's one thing I've really observed the last several years. When you have sufficient N in that flag leaf, it tends to flop over early in the season like that and not stick straight up in the air. Fast forward here to about Feeks 10, we see that same thing. Got your check, your autumn N only, your freeze up, and your green up application. And these differences tend to carry through to harvest time. What we saw a couple years ago, looking at autumn versus freeze up versus green up in 2022, we saw about a 4 to 5 bushel bump going with that Feeks 5 application versus earlier in the season. So again, you start talking about yield potential. You talk about the yen project, all these things. It's going to be incremental steps up that yield ladder, right? I don't think any of you in here are going to go from 90 bushel wheat to 120 bushel wheat by doing one single thing. But it's that synergistic effect, that multitude. You start changing your end timing. You start looking at maybe an autumn nutrient management practice. Maybe you add sulfur to the mix. Maybe you talk to Marty and look at maybe different fungicide timings. It's that 2 to 3 bushel, 2 to 3 bushel, 4 to 5 bushel that adds up over time, right? And so those are some of the differences we saw a couple years ago. We saw that 4 to 5 bushel bump. Applying all of our N in the autumn, kind of, that wild hair idea, we lost about 10 to 15 bushel a couple years back. That late N application, back in 22, going with a Feeks 7, kind of a rescue N application, we gained 14 to 18 bushel on both that freeze up and green up application. And why? It was a wet spring back in 22. You lose more N, you're going to see that response to that later season N application. You start looking at 23, last year, same thing. What did we see? We saw about a 10 bushel bump with that Feeks 5 N application over that freeze-up application. So yes, N timing does matter. And some of it may depend on when did you get planted in the fall. Soybeans were late coming off last year. We had a lot of wet ground. If you got your wheat planted a little bit late, you might want to apply that N a little bit earlier. Why? You can help with that tillering. right? Because you want to be tillered going into dormancy, and if you're not, apply that N a little bit earlier. So we've seen these responses over the last several years. I expect something similar this year based on some of those photos we saw thus far. Wanted to share a couple slides. Marty and I worked on a project the last couple of years looking at interactions between fungicide timing and fertility. Is there something we can take home with if you promote that plant and promote growth and promote development, does it make that plant more receptive and perhaps more responsive to a fungicide application? With the idea being, if you create a lot of wheat biomass, does that plant then, or that environment, become a little bit more responsive to a fungicide application? So what we looked at the last couple of years, looking at autumn starter fertilizer, we looked at about 5 different fungicide timings. We looked at late applied N, about Feek 7 and just beyond. And we did both of these following soybean and corn, right, to see if there was a difference in rotation. So you can kind of see, went with a 1240-0-10-1, an N and S mix for our starter at 0 or 250 pounds to the acre. Went with those 5 different fungicide timings. Okay, and a lot of that was based on that graph that Marty just put up there, looking at that early season fungicide application versus flag leaf versus flowering, and then all combinations that you see there. And then that late applied N, either nothing or about 30 units, again, at about Feek 7. And, you know, does starter make a difference? Absolutely. So here's a picture taken from March 8th to 23, about Feek 2. Look at the differences in development early in the season. Fast forward here to about Feek 4. You can see differences in tiller count, see what those plants look like, about another 48 tillers per square foot, exactly what we want. That's why we go with that starter application. Fast forward to about Feek 5, same thing. We started to see that S deficiency develop. That's that yellowing you see towards the top of that plant where we did not have that fall starter put out. Again, we get to about Feek 6, starter versus no starter. Feek 6, no autumn starter with a F5 fungicide, autumn starter with that F5 fungicide. Then you can start to see as we got to about Feek 10, that sulfur deficiency really took hold. That's that yellowing that you see versus where we had that starter put out. And what do we see for some of our yield results? Well, for one, you'll notice as you go down, look at these lowercase letters. Starter versus no starter, where we had starter fertilizer applied, we didn't see much of a difference with fungicide timing. Now, last year was not a disease-heavy year for wheat. But one thing that does stick out here is we did see some differences where we did not apply starter fertilizer. So one of the things we tend to forget with starter on wheat, especially when you have nitrogen and sulfur, is what does it do? It creates uniformity. And that uniformity does what? It takes away from some of the variability you can encounter in that field. Right? And so what do we want? We want to see a uniform wheat stand. We don't want to see a sporadic wheat stand that has wheat at maybe 3 or 4 different heights that vary in height by maybe 2 to 5 inches. Right? So that's another aspect to using something like autumn starter that a lot of us don't think about. We looked at late season N, didn't see much of a difference. Last year, why? It was so darn dry early in the season, right? No expectation to see a difference show up there. Autumn starter, we did see differences with our straw yield, and that's one thing we've seen probably, I'm going to say about 4 or 5 different site years now in the last 2 years, is you can use that autumn starter to promote your straw production. And why do I emphasize that? Because you can use that additional straw that you get to pay for the cost of that product. That's something we often don't talk about is straw potential, right? So every time we use starter, we see a taller plant, leads to more straw production, leads to more money in addition to your grain yield. Fungicide timing in general last year, again, you can see the 5 different strategies that we had put up there. Not much of a difference across the board. No expectation to see a difference because of those environmental conditions we saw leading up to that point in time. And again, with our straw yield, not much of a difference with that late season applied in. So a couple take-home points. Grain yield. Yes, we've seen benefits to starter on wheat. I got a great study out this year looking at about 7 or 8 different practices again. But I went out, I've done that study a number of years, looking at 7 or 8 different things you can do in the fall. This year I changed it to 7 or 8 different things at a low rate and a high rate, right? Because I've learned over the years, if I say something works at 20 pounds, what does the producer do? Adds 25%, right? So I said, well, I'm going to take a page out of that book. I'm going to do something at rate X, and then I'm going to double it. So we went out with the phos rate and doubled it. Went out with the sulfur rate and doubled it. K rate went out and doubled it. N rate went out and doubled it. Starter rate went out and doubled it. And the differences that we're seeing thus far are quite impressive. But one thing we've seen with this study this last couple of years with fungicide timing and starter and late N, grain yield, yes, we see differences with starter. Late N depends on how much N loss we get early in the season, right? Last year we didn't have much. This year we will have a little bit more. And it's one of those things that, sometimes it only takes about 1 3-inch rain to really drive those N losses. And we've had, depending on where you're at in the state, some of those pop up. Straw yield, yes. We've seen each and every year where we use starter fertilizer, we've seen increases in straw yield because of those differences in plant height. We've seen when we use starter, late N has increased protein, but without starter, or without late N, starter decreased protein. That sounds like you're saying the same thing, but opposite. So this is what we've seen. When we use starter, we get more tillers. When we get more tillers, what do those tillers do? They dilute the nutrient concentration in the plant, so you need a little bit more, right? And so that's what's really impacted our protein content there. Last couple of years, fungicide timing, those 5 strategies didn't see much of a response. That doesn't mean you shouldn't spray, but it was a low disease environment. And we saw plant height and head count were the strongest indicators of both grain and straw yield, and your grain N percentage and N to S ratio in that grain were the strongest indicators of grain protein percentage. That's one thing we've looked at a little bit now, is try to hike that protein percentage based on using starter fertilizer. So we've got derivations of this study out this year. We're going to kind of pull some different treatments out, and I'll share those as we go through this next growing season. Lastly, I want to wrap up with that question that we have on the screen. Who here has ever looked at the heavy metal content of your wheat crop? Raise your hand. Crickets. That is one of the areas we're focusing on now, because this is going to be a huge food quality issue moving forward. So we started a study. We got funding, federal grant last year, looking at how do food crops become contaminated with heavy metals. You read it, it's all over the media, right? Do you want any heavy metals in your grain? Do you not? How did it get there, etc.? That's one of the things we're starting to take a look at. The government came out, or the Food and Drug came out with a Closer to Zero action plan, I believe 2 or 3 years ago now, trying to reduce exposure to heavy metals, specifically to infants and young children. Working with Nestle, working with Gerber, I've learned one thing over the last couple of years: you do not mess with baby food. There is zero room for error with baby food, right? And a lot of these food traits are going to carry over to other cropping systems, right? And so how do some of these metals get into some of these crops? So we're focusing specifically on arsenic, cadmium, and lead. And some of the repercussions of having these in that grain. The Food and Drug Admin will set maximum levels for these metals in food, which will impact the entire food supply chain. It's going to impact the processors, it's going to impact you, the grower, etc., moving forward. And so right now we're focusing on 2 specific cropping systems. We're looking at both carrot and winter wheat. Both are ingredients in baby food. You start thinking your cream of wheat cereals, things like that. We need to understand what drives that heavy metal uptake. And this is a very complex issue. And why? Because it's not driven simply by the presence of a heavy metal. We've got data that shows fields that when you soil test, the heavy metal's not there, but all of a sudden, come harvest time, they're all over in the plant. How did that happen? Is it environmentally driven? Yes. Is it crop driven? Yes. Is it topography driven? Top of the hill versus middle of the hill versus bottom of the hill? Absolutely. So all these factors. Is it this weather that we're having, where we get 4 to 8 inches of rain in 2 weeks, and then we go through 8 weeks of no rain? Absolutely. It really changes the soil chemistry, and all of that can impact that heavy metal solubility. And so we're looking at specifically how to get the grower to understand how these metals get uptaken in these crops. We're working with food processors to figure out maybe where certain fields should or should not be harvested for some of this content. You know, and it's a complex issue because a lot of these fields get tested prior to planting, right? And so soils that test high in heavy metal, maybe low in pH, are already excluded, right? So that's the low-hanging fruit. And no, this isn't old orchard grounds that we're dealing with either, right? So we've seen fields that all of a sudden that have very little heavy metal presence shows up in that carrot crop, or it might show up in that wheat crop. And I'll tell you one thing, if I'm growing 100 or 200 acres of carrots and I get my entire field rejected because it's high in a specific heavy metal, do you think I'm going to grow carrots there ever again? Probably not. And then how much is safe? We don't know. How much shows up in the soil, how much of that translocates to the plant? We have no idea. Right? And so those are the things we really want to take a look at. So we're looking for where some of these hot spots occur in some of these fields where crops tend to accumulate some of these heavy metals at higher concentrations that then lead to that crop rejection. And we're going with how can we mitigate? In some cases, plant breeding can take care of this over many, many years. Right? We might be able to breed germplasm that does not uptake a specific heavy metal. But that does not help the grower right now or in the near future. Is there something we can do to the soil to specifically negate uptake of some of these metals? So that's what we're looking at, trying to decrease the bioavailability of some of these heavy metals in soil and try to figure out when it's uptaken in a wheat plant, carrot crop, something like that, and where it ends up. Does it end up in the grain? Does it end up in the flag leaf? Does it just end up in the stalk? So that's a couple of things we're working on. We'll have more data on that coming up here as we get through this growing season. So with that, I'll wrap up. Perhaps have time for a question or two. Otherwise, I'll stick around for a bit yet for any of you that want to ask me something later on. Yes?
With your rotation of corn silage, soybeans, and wheat, and then selling the straw, how are you going to replenish your organic matter?
That's a great question. The question was, with rotations that include corn silage, soybean, and wheat, and removing straw, how to replenish organic matter very carefully. Right? Great question. That's one of the things we have to account for with straw removal. We remove a heck of a lot of nutrients. A heck of a lot of potassium comes off that field, right? We have to account for that. So I look at it more from, it's more than just an organic matter issue. It's a nutrient removal issue. Right? And you look at the cost of potash 2 years ago, heck, even 18 months ago, may not have been worth it, right? But some of those prices have dissipated a little bit. And so again, yes, that is something you need to account for. Now, is it going to vary by region? Right? I look at soils up here in the thumb versus south central Michigan versus maybe on the western part of the state. A lot of differences, a lot of variability in those soil physical and chemical properties, right? So you look at potassium content up here versus south versus west, big, big difference. But yes, you bring up a very good question. Anytime you remove residue, you have to still account for that nutrient removal that you're removing from that field. The organic matter question, that's a tough one. We don't build organic matter quickly, right? Lots of soil amendments we can put out there that might help address that topic. But again, we're not going to build large percentages of organic matter quickly. And anytime we take residue off, a lot of that residue that we pull off may not necessarily contribute to long-term organic matter additions. But again, you start talking about significant crop rotation, diverse crop rotations, et cetera. That's probably a bigger answer to our soil health and organic matter question. Other questions? In the back. Yep. So the question was, with regards to the nitrogen, have we done much with slow-release nitrogen paired with soluble N sources? Absolutely. We've looked at polymer-coated products. We've looked at which are controlled release. We've looked at slow-release foliars. We've looked at nitrification inhibitors. We looked at urease inhibitors, any combination of all of the above. And yes, oftentimes it is good to pair a soluble and maybe a controlled release source together. The one thing you have to account for is with some of those controlled release products out there, you still need water to get into these prills to then release that nitrogen, right? And so to use 100% maybe controlled release product may not be smart because it doesn't give that plant anything at the get-go. The one thing I will caution everyone on with a lot of these products in wheat is wheat grows darn quick, right? We all think crops grow like corn do, right? And wheat does not. Wheat puts on the bulk of its biomass in about four plus weeks from about mid-April to about mid-May. And so with some of these products you have to caution yourself on is you can inhibit and release, and you might inhibit it too long that you miss the growth window for that wheat crop, right? And so that is one fear factor. Probably, 12, 13, 14 years ago now, when a lot of these nitrification inhibitors came on board, we worked with them, a lot of them in wheat, and in some cases we inhibited that ammonium to nitrate transformation too much, and it held that N up in that ammonium form, and that N was not released till well after that wheat crop was headed out and we saw yield reductions. Right? So with wheat, because it grows so quickly and early in the season, that is something you need to account for. So I'll wrap up there. If there's any more questions, I will stick around for a while yet. Otherwise, I appreciate everyone's time today. Thank you.